Okay. Good morning, good morning. Thursday already? I can't believe it. Let's get to it. So you've got your test next week. So test one, number one on Thursday, right? Which is October 15th, I want to say. Let me just make sure. Yeah. So we'll do review next day, but also kind of make sure that everyone's on the same page with how the test is going to go, because obviously it's going to be different this term. So we'll just kind of talk about that as well as any problems that you might want to bring up that we should work through. Okay, so I'll post the practice test. I don't have one ready yet, but I did post on Moodle. Let's see here. It's gonna boot me out here. Okay. So I did post, so the 1.3 solutions I got done earlier. And then I posted section 1.1 because there were no problems in 1.1 and 1.2. So I posted those, and then the solutions are at the end. And then, oh, they added in a different order, but that's okay. They're obviously labeled. So so you can have a look at those. So work through the problems that are in the notes, right, as practice, and then make sure to check against the solutions. And of course, if you're working through these things and something's not working, then let me know right away. Okay. So go back here. So we will do review on Tuesday, which is the October 13th, the day after Thanksgiving. Okay, so just as a quick reminder of what we did last day, we did inequalities. We talked about linear inequalities, linear, nonlinear inequalities. For nonlinear inequalities, right, we had to make the number line and figure out where the equation satisfied the inequality, right? And so and then we talked about the absolute value inequalities as well. And then I said, give 51 a try, and then we'll do it as a review next day. So from section 1.8, number 51 was, oops, x plus 2 times x minus 1 times x minus 3 has to be less than or equal to 0. Oops. Okay. So what we said before is a recap, right? Linear inequalities, I'd say, are kind of fine as long as you have a little stopper in your mind, right? As long as you're not multiplying or dividing by a negative number, then you can just go ahead and treat it as an equal sign. There is that little caveat with the, if you've taken the reciprocal, but it doesn't really come up, but if you end up doing that, then keep that as a mental stopper as well. But mostly the negative, right? If you're multiplying or divided by a negative, then you need to switch the inequality, right? So for the linear inequalities, kind of fine, right? The nonlinear inequalities are a little bit harder. So what we need to do is, if everything wasn't over on one side and then 0 on another side, you would have to smush everything over so that you end up with just 0 on one side of the inequality, right? And then you would want to factor things until you can't factor anymore. So something like this, right? And then, so now we know the solutions of this thing where it equals 0. So that's where it crosses the x-axis, right? So it crosses at x equals -2, right? Because that would make this 0, and then 0 times anything makes 0, right? So it crosses at -2, at +1, and at +3. Okay. Now, because if we expanded this, we would have an x to the power of 3. We might have something that looks like this, right? We don't need to know what it looks like. In fact, I'll show you on Desmos. I can't remember if I've shown you guys Desmos yet, but we'll have a look at Desmos. It's a free app. You don't need an account or anything, so it's nice. It's just a graphing calculator, essentially. Okay, so what we need to do is we need to find the solution. So x equals -2, x equals 1, and x equals 3 is where this equation crosses the x-axis. So what we do is we set up a number line, right, from last day. We say, okay, well, I need to know how it behaves on either side of all these points. So I'm going to break this up into -2, oops, and it doesn't need to be proportionately spaced. It's just for visualizing and working on figuring out what this thing looks like. Okay. So we use these to make our check-in points, because what happens is this expression is going to behave the same way for all values left or less than -2. For all values between -2 and 1, it'll behave the same, and same thing between 1 and 3, it'll behave the same, and then from 3 onwards, it's going to behave the same. So we just need to pick little values in between here, and it can be any value. I encourage you to use convenient values, right, if you can. My go-to is always 0, so I'm going to be able to use 0 somewhere in here, right? But the point of these test values is really just to be able to figure out what the sign of this is, right? We're concerned with how does it relate to 0, so we want to know, when is this thing less than or equal to 0? So when is this thing negative, right? And so here, looking for when the expression is negative. Right? Oops. Oh. Okay. So we can use little test points. I'll use x equals, I don't know, -3, why not? But I'm really just trying to figure out the sign here. So even if you don't want to use test points, you don't have to use test points, but you do need to figure out the sign in each of these regions. And the test points just, I find, are really helpful. My go-to, x equals 0. Here, x equals 2 might be nice, and here, x equals 4, why not? Okay. So what we're going to do is I'm going to write out this expression, right? And just try to figure out, okay, if x is less than -2, anything less than -2, well then this thing, right? And I can kind of check in what it would look like using x equals -3. -3 plus 2 gives me a negative, right? And then I go through each of these. So what I have is I have x plus 2 times x minus 1 times x minus 3. I want to try to write it pretty small because I want it written out in each of these regions. In fact, I'm going to cheat, do a little copy, paste, paste, and paste. And just to help myself mostly, I'll just separate these regions so I can keep track of which region is which. Okay, so like we started here, if I let x be -3, this is going to be a negative value. A negative value times, if x is -3, -3 minus 1 gives me another negative value. -3 minus 3 again gives me a negative value, which a negative times a negative times a negative gives me a negative, right? Negative times a negative makes a positive. And last day we only saw 2 things, but we could just as easily have 3, 4, 5. It just gives us more check-in points, right? So negative times a negative times a negative gives me a negative value. Which is what I'm looking for. Okay. Do the same thing for the next one. So now I'm between -2 and 1. Anything between -2 and 1 is going to behave the same in here. So I'm going to use 0. So 0 plus 2 is a positive value. 0 minus 1 is a negative value. 0 minus 3 is a negative value. And so I get positive times a negative makes a positive number, which is not what we're looking for in this case. So that's why I used red. Right. Picking up the pace a little bit here, if I let x be 2 in here, then I get a positive. I get 2 minus 1 is still positive. 2 minus 3, that's negative. So I get positive times a negative makes a negative result. Kind of weird to put negatives in green and positives in red, but since we're looking for negatives, that's what the colors are all about. And then if x is 4, 4 plus 2 is positive. 4 minus 1 is still positive. 4 minus 3 is still positive. Yeah. Positive times a positive gives me a positive, which is not what I'm looking for. Okay. From here, right, knowing when it's negative, positive, actually tells me a lot about the graph of this thing, right? And so we could guess, right? We could guess that if it's negative here, so if we make this our graph, we have x equals 0 somewhere here, then here at -2 and 1 and 3, because this is what it's going to look like. Oops, that's supposed to be a 3. Well, if it's negative up to this point, and then it's positive, and then it switches to negative, and then it switches to positive, right? I might have something that looks like something like that, right? And so this thing is less than or equal to 0, right? Less than or equal to 0 from -infinity to -2, right? And then again from 1 to 3. So the solution is from negative infinity to negative 2. Negative 3 was my test point. Or, right, use that union, or from 1 to 3. And then I want to just check in. I used round brackets. I have to use round brackets around infinity because infinity is not a number. But I used a round bracket around negative 2, 1, and 3. But I just want to check in because I want to know when it's less than or equal to 0. And it's equal to 0 at all of these points. And so I should actually be using square brackets around these things. So here, I'll just put that this is the graph, or I'll say potential graph. So that is the end of our review. But what I want to do is I want to show you guys how to use Desmos just to check your work for this stuff, right? So as you can see, it's very helpful to have the graph, right? Because then you can say, okay, well, the result is going to be negative. So below the x-axis is when it's negative, and above the x-axis is when it's positive. So up until negative 2, it's going to be negative. From 1 to 3, it's negative. Okay. So what I'm going to do is I'm going to try to remember, and I think I might still have left it in Desmos, but that's okay. What I'm going to do is I'm just going to type out this expression in Desmos. So Desmos, if I haven't shown it to you already, I don't have a pointer on here, but Desmos is this green graph looking app. And just to show you how to enter stuff, I'll get rid of it. So you can tell I'm not logged in or anything, you can just use it right away. And what you do is you use the little keypad at the bottom to tell it what to graph, right? And so I want to use the exact same expression that I had in the question. So the original expression was bracket x plus 2 and bracket times x minus 1 and bracket times x minus 3 and bracket. So what's nice and kind of fun is that it gives you, if you click on these little points here, it gives you some points of interest, right? Even if you wanted to know, you could kind of trace along the line and figure out what the point is at each of these values. And so you can move along through values of x, and you can see that the result, so the y value is negative up until you hit negative 2, and then it switches to positive, right? And so you can check your work using Desmos. Okay. And hey, that's what we said our graph probably looks like. Okay. So pretty good. Cool. All right. I have not seen any questions. So, oh, how did I get the points to appear? I clicked them. Bink, bink, bink. You can't see that because you can't see my pencil. But if you just click the dots, you can use your finger too. They show up, and then if you trace along, now I'm using my finger, it works the same. Trace along the line. Cool. Cool, cool. Nice. So definitely worth checking out, especially because it's a really nice way to be able to check your work, right? Make sure that you've got the right solution. Okay. All right. So 1.10, after the stuff that we just did, is going to feel like I'm missing something. No, you're not. It's gonna be really fun, really easy. It's just about straight lines, right? So drawing lines, how do they behave? What's the slope? What's the intercept? Which probably sounds familiar from some point. Pun intended. And then at the end of the fundamentals part 4, which is the very end, is 1.11. 1.11 is actually just basically using Desmos to solve stuff, but that's what I just showed you. And so we'll see if we have time to get there. Otherwise, I'll just leave it for you guys to work through because it's really just using Desmos to graph stuff and to be able to find answers. So we'll focus on 1.10 and then we'll see if we have time to go through 111 together. If not, you're on your own, and that's okay. You'll be fine. Okay, so just getting into lines, right? We first have to talk about the slope. The slope of a line is really just, is it positive or is it negative? And then how steep is it, right? So a line has a slope, right? Which tells us two things. The first one is whether the slope is, or whether the line is going in the positive or negative direction, right? So if it's positive or negative. So in general, a positive slope, if we're just looking at an XY axis like this, a positive slope is something that's going up, 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 up. Okay? Whereas a negative slope looks like this, where it's going down, 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 down. So that's the first thing. If you have a positive slope, so it'll actually be a positive value, right? Then you're going up, up, up. And if it's negative, then it's kind of nose diving down. Okay? The second thing it tells us is how steep the line is. Steepness? Is that a word? It is now. What's the word I'm looking for? I guess steepness. I'll play it safe. How steep the line is. Hey, it's even in the notes. Steepness. I'll go pull it in. How funny is that? Here. We first need a way to measure the steepness in quotes. So I guess it's not a word, but it is something we use. That is really funny. I'm like, hey, I'm weighing it. I guess not really. Let's talk about the slope of a line first. So we usually use a lowercase m for the slope. So lowercase m is the slope. Okay. And hopefully you remember rise over run, right? Rise over run in terms of points on a coordinate system. Right? And what we'll do is we'll just talk about just the positive quadrant for now. So here's your x-axis, here's your y-axis. Okay, and here is 0, 0. Okay. So then if I've got a point at x1, y1. Okay. And then I've got a point here at x2, y2. So remember, in general, we can use these ordered pairs, right? X first, comma, y, and we use the round brackets around those ordered points. So now what we'll talk about later is all you need to draw a straight line is 2 points. And then you take a straight edge. You can just kind of take the edge of your paper or your calculator or something straight, and then you connect the two. So let's go here, connect the two, and draw a line through it. Missed a little bit, but that's okay. I would redraw it, but. So I'll just make this dot bigger because it's an arbitrary dot anyways. Wink. Solved. So what we want is we want to figure out, well, what's the slope of this line? Notice that the slope of the line is going to be the same regardless of these 2 points, right? So even if this point was moved closer here, what we would find is that the slope is the same. So the rise, because it's, I hope that it's, you know, kind of second nature. Okay, the slope is the rise over run, but what does that mean? Well, the rise is the distance from here up to here, right? And so in general, it's this distance here. So what we do is we need to take the second point minus the first point of y, right? And so that's where the y2 minus y1 comes from. So the rise, let's use maybe green. So this distance here, from here to here, is the rise. The rise is the distance between y2 and y1. Because y2 is going to be larger than y1. Even if you've got a negative slope, so that would change this, y1 would be larger than y2, but that's okay because that's how you generate that negative, right? And so if y1 is larger than y2, then you get a negative number, and that's how you get that negative slope. So you actually always do y2 minus y1. And then for the run, let's see if I've got a different color here. The run is the distance between here and here. So the run is the distance between x2 and x1. Same idea. Okay. And so if the slope, oops, I should write it different order. The slope, which is m, is going to be the rise, which is y2 minus y1 divided by, I'm going to try to keep it clean here, divided by the run, oops, which is x2 minus x1, and I want the neutral blue. Okay. So that's where the slope comes from, right? And the slope, right, just tells us how steep this line is. If you've got a large slope, then you've got a really steep line. If you've got a small slope, then you've got this kind of shallow line. Okay. Let's talk about how do we write, well, before we do that, most often when we talk about lines, we talk about y equals mx plus b. Hopefully that's kind of ringing a bell. Y equals mx plus b is just the typical form of a straight line, right? We could also talk about the point slope form of a line, right? So this is called the slope-intercept form of a line, and this is the point slope form of a line. And so we'll talk about, well, maybe we'll talk about the slope-intercept form of a line. The most common way of, I shouldn't say way, equation of a line. The most common equation of a line is the slope-intercept form, which is y equals mx plus b, where m is the slope and b is the y-intercept, right, where it crosses the y-axis. So I'll paste this in here. Another way that we could generate an equation of a line is the point slope form of a line. So another way we could generate, because notice you have to know the slope and you have to know the y-intercept in order to put it together and make this equation of the line. Sometimes you don't have this. Sometimes you have maybe a point and the slope. So another way we could generate the equation of a line is the point slope form. You're going to get to the same thing, and I'll show you how in just a second. Point slope form of a line. So if we're passing through any point x1, y1, then, and we know the slope m, just any m, then what we do is we use this equation, y minus y1 is m all times x, or x minus x1. Okay. So, for example, if the point we know is x1, y1, which is going to be the, I'll let it be the y-intercept, where x is 0, y is b, is the y-intercept then what do we have? So if we use the point 0b in place, so 0 wherever we see x1 here, oops, and b, a lowercase b, wherever we see y1. So then what we get is we get y minus y1, I'll write out the general form first, times m times x minus x1. So then I get y minus b is m times x minus 0. Okay. Now, I can solve for y here by adding b to both sides, right? And x minus 0 makes x, so then I just have mx plus b is what I end up having. So y equals mx plus b. So now we're back to the slope-intercept form of a line. Back to the slope-intercept form of a line. Okay. So I'd say the point slope form of a line is more flexible, right? Because you can put in any point, and as long as you have the slope, so as long as you know the slope and some point on the line, you can generate the equation of the line, right? The slope-intercept form requires that the point be exactly the y-intercept, which is not necessarily the point that you have. Okay. So, there are a couple of different, so there's, I guess we can do one just to see, but it's just going to be finding the slope. So if you have 2 points, let's do, oh, no, I don't want to do that one quite yet. I want to do maybe, well, because I don't want to do a huge graph. I'll do this one. So 14, I'll try to squeeze it in here, has a point P. So we're trying to find the slope of the line through P and Q. Okay? So essentially what we want to do is we want to do what we did up here, but now we know what P and Q are, right? And it doesn't matter which one's P and which one's Q. So what we'll have is P is going to be at 4, 3. So when X is 4 and Y is 3. So I'm going to check out where I need to draw my axes first, right? And so it looks like, okay, I need an X up to 4 because the other X is +1. So if I go to 4, then that's enough. And same thing for my Y's, I need up to +3, but also down to -1. So I'm going to put those on here. 1, 2, 3, 4, 5 for good measure. And then 1, 2, 3, 4, 1. So -1, 1, 2, 3, 4, 1, 2, 3, 4, 5. Okay. Of course, this is a really rough sketch, but that's okay, right? Because I want you guys to practice drawing out, well, figuring out what you need for your axes is really important. But also to be able to plot these points is going to be good and something that I assume that you already know how to do. So at 4, 3, so when X is 4, 1, 2, 3, 4, Y is 3, so somewhere here. 4, 3-ish. And this is, I'll put a P out front. P is at 4, 3. Oh. Now, Q is at 1, -1. So here I've got Q is at 1, -1. So you can use the formula for the slope, right? But here, if I connect these 2 dots, it looks like I get a positive slope, right? Or I do get a positive slope. So just make sure that your result is positive, otherwise you've done it wrong. Okay. So if we have the slope is y2 minus y1 over x2 minus x1, and I'll try to keep it on the same page here because I'm dealing with a page break here. So that's why I'm writing across. So if I want y2, I'll let this be my y2. It doesn't matter, right? Y2, or if I use -1 as my y2, that's fine too. 3 minus -1 divided by x2, which is 4. So now I use this as my 2, or as my second point, right? So this, I have to be consistent. So the x2 is 4 minus x1, which is 1. 3 minus -1 makes 4. 4 minus 1 is 3. Notice that I've got a positive slope here, which is what I'm expecting for this positive line. Okay. Nice. we have to talk a little bit about vertical and horizontal lines. Okay, so a vertical line is something that goes like this, right? So it's straight up and down like this, and then horizontal looks like this. And I used to have a hard time remembering which one's horizontal and which one's vertical. But if you think about the horizon like this, then that's horizontal, and then vertical is the other way. So we can have, of course, we can have vertical or horizontal lines. Okay, so here, I'll draw it like this. So if you've got a line at x equals a, what does that look like? Well, it looks like you might have some x equals a, and this is the line running through it. Now I need it to be, just pretend that's straight vertical. Right. So here, it doesn't matter what the y is, x is always just going to be a. So this is a vertical line. Versus a horizontal line, so is when y equals b. So it doesn't matter what x is, y will always be b. So here at y equals b, oh, should move that down a little bit because I want to draw my line through it. Y equals b, this is a horizontal line. And they're supposed to be straight. It's hard to draw. So a horizontal line has a slope of 0, whereas a vertical line actually has no slope. Slope equals 0, and this has no slope. If you think about rise over run, well, here the rise is 0 because it doesn't change, right? It just keeps going straight across. 0 divided by anything is just going to be 0. Whereas here, if you're not moving, if there's no run, then the rise can be as large as you want, right? You can pick any value here, and the rise can be anything. But the run is 0, and we're not allowed to divide by 0. We can't divide by 0, and so we have no slope here. Okay? So that's important to keep in mind. Okay? So if we have these problems that we can work through, make it a little bit bigger. Okay. So we can find equations of these lines, right? And if you go back to the point, right, the reason I didn't want to do this last one is because the y value is the same for each of these. So if x is 3, right, 3, then y is -2. If x is 6, then y is -2. What does that give me? This last one would be a horizontal line at y equals -2, right? So just go back and try that one, but I wanted to introduce the horizontal and the vertical lines first. So there are a couple of different ways that we could get information from a line, right? We're not going to do a ton of these because I want to just be able to draw any line given the equation, but you could be given the slope and the y-intercept, right? Then you can go ahead and just use y equals mx plus b, and we can just plug in some values here. So for 23, right, y equals mx plus b. If the slope is 3 times x plus the y-intercept is -2, then I have y equals 3x minus 2 is the equation of my line. 24, you're given the same information, just different values, right? So if you're given the slope and the y-intercept, that's fine. The next few problems are going to be point slope form, right? So you're given some point and it's not the y-intercept anymore, and you're given the slope. That's when you're going to use that point slope form of the line. And then finally, right, kind of a little jogger here, 29, you're just given 2 points, but you can use those 2 points to find the slope. And then you can use the point slope form because you have 2 points to choose from. You only need 1. All right, so you can use these to find the slope, and then you can find the line using the point slope form. Let's do 27 because it looks a little bit trickier. So 27 is a line through 1, 7. Oops. Helps if I draw it or write it properly. 1, 7 with a slope of 2/3. Okay. So I have a point and I have a slope. So point and slope. Therefore, I use the point slope form of a line. Which is y minus y2, or sorry, y1. Y minus y1 is m times x minus x1. Where x1 and y1 come from the point, and m is the slope. So now I'm going to plug in my values. Y minus 7 is the slope of 2/3 times x minus 1. So I can solve this for y to make it an equation of a line, right? The equation of a line has the form y equals mx plus b typically. And so you want to solve this for y to get it to look a little bit nicer. We're dealing with fractions though, so that's fun, but we're feeling good about fractions hopefully. So we get y is 2/3 times x minus 1 plus 7. This 2/3 is multiplying x minus 1, so I'm allowed to multiply it in to get rid of these brackets. So we get 2/3x minus 2/3 and then plus 7. Okay. The x is on its own, so that's fine. But now I need to combine these to get just one intercept, one y-intercept. Right, so -2/3 plus 7, I need a common denominator. And so what I'm going to do is I'm going to have y equals 2/3x minus 2/3 plus 7. And then remember, just the easiest way to get that common denominator of 3 is just to multiply by 3/3. Now I get y equals 2/3x minus 2/3 plus 21/3. Now I can add these two fractions, making sure I keep this -2/3 as a negative, right? And so it's 21 minus 2, putting me at 19/3. Y is 2/3x plus 19/3. I'll just use my calculators to make sure that is simplified, and it is. Right? So, a little bit trickier, right? But not bad. As long as you remember how to deal with fractions, it's not that bad. Okay. So the general equation of a line is actually not y equals mx plus b. It's of this form, right? So the general equation of a line has the form ax plus by plus c equals 0, right? And so we've seen this kind of setting things equal to 0 in the quadratics, in the inequalities when we're solving inequalities, right? And so this is the graph of every linear equation, right? And so if there's one x and one y and potentially a constant, there's room for a constant, and you're able to set them to 0, then this is a line, right? So if we have a look, right, we can rewrite the general equation of a line. The general equation of a line as y equals mx plus b if we solve for y. Just to show that we can work backwards, forwards. So if we solve for y, so we have ax plus by plus c equals 0. It's important to recognize, so if you see something like this, this is a straight line. So I'll highlight that. If you see something of this form, it is a straight line. So if we solve for y here, right, I want to get y on its own. So I can slowly start moving things over. I can move the c over, I can move the a over. And so I can be left with by is negative c minus ax, right? Moving things over a little bit faster. And then y is going to be negative c minus ax over b, which I can rewrite as y is negative, and you can pull out a common negative if you wanted to. I'll just keep them as they are. Negative c over b minus ax over b. A little bit trickier, right? But here, this would be our y-intercept, and this would be our slope. So whatever is attached to the x is the slope. And so this is your y-intercept. And then this here is your slope. Oops. Okay. A little bit trickier. I would say you can probably just solve for it. You don't have to memorize these. You can just go through every time and use these steps, because then it's easier to graph them. So like we said, to graph a line, all we really need are 2 points on the line, right? And then we just connect them with a straight edge, and then we extend the line, and the line just keeps going, 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 going. So it's kind of in big. I added it in there, so may as well use it. Okay. So drawing a line is not that bad. So let us, I'll put these problems here. Maybe I'll make this a little bit smaller. Hey. There. How about that? Same page. So if I want to graph this line, right, what do I need to do? Well, I need to find 2 points on the line. Right? And so it says find the slope and y-intercept of the line and draw its graph. Okay? So there are 2 ways that you can draw a line. I like to just find 2 points, connect those points, and be done with it. Right? Another way is that you could find 1 point and then trace over with the slope, right? Okay, so the rise has to be this, the run has to be this. I don't like that way. So to find 2 points on the line, we can pick any 2 values of x. We can pick any 2 values of x and use the equation to solve for the y value. And use the equation to solve for y. Right. So usually how I do it is I set it up as a little table here. So if I have x and I'm going to pick 2 values of x, so I leave room for 2 x's. And then I've got my equation, so let's draw, I don't know, let's draw 59. Right, so 59, for example, I've got negative 2x plus y equals 7. Sometimes it's easier if you just solve for y first, right? Because you're trying to plug in a value of x and then solve for y. But if you're doing it twice, you may as well solve for y and then plug it in. So here, this becomes y equals 7 plus 2x. Right? So now, if I pick just, and I want to pick easy values of x to plug in here. So I'm looking here, what's an easy value? Well, x equals 0 is a really easy value, right? And especially if I'm drawing a graph, then x equals 0 is nice and accessible. And so x equals 0 is one of my go-tos, right? So then we have y equals 7 plus 2 times 0, which is 7 plus 0. So then I'm at 7. So then the point, right, in x comma y, so as an ordered pair, right, the point that I'm looking at is at 0, 7. Right? When x is 0, y is 7, 0, 7. Moving on to the next one. I'll pick another easy value of x, right? Maybe 1. Might be nice. If x is 1, y is 7 plus 2 times 1, which makes 9. So then this next point is going to be, 1, 9. Pick any values of x, right, is what we're doing. Okay, so now if we have to graph this thing, and I'm just doing a little fakie here, right? looks like my y's, especially for the points that I picked, have to go up all the way to 9. So I might do 1, 2, 3, 4, 5, 6, 7, 8, 9, 11. This one has to be equally small, so maybe I picked kind of bad values of x, but that doesn't matter. So if x is 0, y is 7. So 0 is here on the y-axis, and then I have to go up to 7. So 1, 2, 3, 4, 5, 6, 7. Of course, it's not to scale, but that's okay. And then the next point is at 1, 9. So 1, 9. Now I'm going to connect this line. I'm just using the straight edge of my calculator here. You can use anything you want. Now we've drawn a line. Okay. So the key is to just pick at least 2 values of x. Sometimes it's nice to have more than 2, just to make sure that you're doing the right thing. But you only need 2 points, and then you connect them and extend the line. Okay. Yeah, that's good. I was thinking we could do another example, but let's talk about parallel and perpendicular lines, and then we'll graph some of those as well. Okay, so parallel and perpendicular lines, let's talk about parallel lines first. Parallel lines are lines that go like this, right? And so they move in the same direction the same way. So 2 non-vertical lines, so they can't be like this. So 2 non-vertical lines are parallel if and only if they have the same slope, right? And so 2 parallel lines look something like boom, boom. Okay. If they have the same slope, let's see here. Same slope means they'll never cross, right? So even if one had a slope like this and one had a slightly different slope, eventually, because these things go to infinity, negative infinity, eventually they would cross at some point. So there would be some sort of intersection. So the same slope means there will never be an intersection. Right, the lines will never cross. So that happens if they have the same slope. Okay. Perpendicular lines are a little bit more fun. Perpendicular lines are lines that go like this. So if you've got a line here and then you've got a line here, there's a 90-degree angle or a right angle here between the two. We won't talk about that because we're not in trig quite yet. I can't remember if I copied this. I think I did, but better safe than sorry. Okay, so 2 lines, so one with a slope of m1 and one with a slope of m2. Notice that we use these subscripts just to denote, okay, I've got a slope here, I've got m1, m2, x1, x2, y1, y2, right? So we just use these little subscripts to denote that we've got multiple of the same thing. Our perpendicular, if and only if, and here's the weird part, m1 times m2 has to equal -1, right? Or another way, we could solve for m2 and say, well, m2 has to be -1 divided by m1. Sometimes it's easier if you have the 2 slopes, you can just multiply them together. to see if they equal -1, and that would tell you that they are perpendicular. Or if you have the two slopes and you can look at them, then and see if M2 is 1 over -M1 or -1 over M1, it doesn't matter, as long as you have the negative on the outside. And then a horizontal line, right, is perpendicular to a vertical line, which has no slope, which is kind of a caveat there. But in general, we're going to be talking about, okay, are these two lines perpendicular? Or even I could ask, well, what's the slope of a line that is perpendicular to this, this other line? So let's work through some problems here. Oh. So the equations of two lines are given. Great. Determine whether the lines are parallel, perpendicular, or neither. It can be neither. So here I've got just two equations of a line. This one's in slope-intercept form, and this one is in the general form, right? As long as we're recognizing that all of these are just lines, right? Then we can solve for the slope, right? We can figure out what the slope is for each of these, and then we can go from there, right? So let's deal with, let's do this first one, just to warm up. You have y equals 2x plus 3, and 2y, minus 4x minus 5 equals 0. That first one, it's easy. You look at it and you see that the slope must be 2 because it's whatever is attached to the x. Everything is simplified, and so it's whatever is attached to the x. So here, m1, let's call it, is 2. Okay. Which one you call m1 and which one you call m2 doesn't matter. I'm just going to go in order. Here, for this next one, I'm going to need to solve for y first because I find that that's the easiest way to figure out what the slope is. So here, solve for y to find m2. So if I've got 2y minus 4x minus 5 equals 0, easy enough to move everything over. Oh yeah, so you could go through and use that, the one that we just developed up here, right? The general form, you absolutely could use that because you know what A is, you know what B is, and you know what C is. I actually find that it's easier to just solve it every time. But if you want to, you can use this one. But I don't like to memorize stuff, so I just solve for it every time. But absolutely, if you've got it on lockdown, go for it. So we've got 2y. I am going to be a little bit quicker because we should be pretty comfortable solving for y by now. So now we've got 4x plus 5 on the right-hand side. And then solving for y, I get 4x plus 5 all divided by 2. Now, if I split this up, I have to be careful because both parties are being divided by 2. So I get 4x divided by 2 plus 5 over 2. 4 divided by 2 I can simplify. And then 5 over 2 I can just leave as is because we're just talking about the slopes. So this becomes y becomes 2x plus 5 over 2. So then m2 is also 2. So what I'm going to say is that, because I always want to justify what I'm saying, right? Since m1 equals m2, these two lines are parallel, right? If they have the same slope, then they're parallel. So since m1 equals m2, and I'm just going to say what the equal to, oops, m2 equals 2, these two lines are parallel. So what I want to do is I want to just show you how to graph two lines in Desmos. And so if we go to Desmos, it's pretty clever. You can plug in, so if you have it set equal to y, right? I don't see an equal sign. Oh, I do maybe. Okay, let's try it. If we have y equals, so I'm just going to plug it in just as it says here, 2x plus 3 seems to know what that line looks like. So what I can do is I can use the little kind of return button down at the bottom, it's blue, and then it'll let me put in another line. Okay, so like I said, it's pretty clever. So I'm just going to plug in 2y minus 4x minus 5 equals 0 and see if it can handle it. 2y minus 4x minus 5 equals 0. And there it is. Okay. You can just check your work. Yeah, it looks like they're parallel. We won't really know unless we actually check the slopes, but we already found that the slopes are the same, so it checks out that things are parallel here. Good. Let's do, oh, I wish I had gone through these and figured out which ones are which. We'll work through a couple of these. Let's do, which one? Let's hope 76 are maybe perpendicular. Or maybe neither, as long as they're not parallel. We'll see. 2x minus 3y equals 10, and 3y minus 2x minus 7 equals 0. Okay. Neither of these are in slope-intercept form, so I'm going to need to solve for y in both of these scenarios. So usually what I'll do is I'll just label this 1 and 2, right? Equation 1 and equation 2. And then when I do work, then I can kind of link the two. So here I'm going to have 2x, whoa, what happened? 2x minus 3y equals 10. If I'm solving for y, they're parallel, says Desmos. Thanks, Tim. We'll do them anyways. Bad choice. Nice to solve for y though again. So we have negative 3y is 10 minus 2x, so y is 10 minus 2x divided by negative 3. And so I have y is negative 10 over 3. Often if I have a negative down here, well, so the test is you're just writing it at home, so you'll have access to anything you want. So definitely use Desmos to check your work. Yeah. So, and I think it makes sense because in life you'll have access to anything you want. So if you know how to use these things, then that's way more valuable, I think, than me just kind of grilling you. Yeah, so definitely kind of get comfortable with Desmos because it's a really good tool for just checking your work, right? Especially graphically. So if I just keep going here, 10 over negative 3, I can rewrite as negative 10 over 3, and then minus 2x over negative 3, but this negative goes away to make a positive over 3. So the slope here, let's call it m1, is 2 over 3. And then for my second equation, looks nasty here. 3y minus 2x minus 7 equals 0. Solving for y, I get 3y is 2x plus 7. Oh, it doesn't look good. Y equals 2x plus 7 divided by 3. Y equals 2 over 3x plus 7 over 3. Oh no, m2 is 2 over 3, just like we already knew. Since m1 equals m2 equals 2 over 3, these lines are also parallel. How about I work backwards? How about I try to find perpendicular lines or something that looks perpendicular from plugging in one of these equation pairs? Y equals, now the 1 over 2, you want to be really careful, right? Because now if you keep typing, it'll put it next to the 2. So you want to step up. So if you just give it a dot, so you have the 1/2 x plus 4. Then my next line is 2x plus 4y equals 1. Doesn't look parallel, or perpendicular rather, right? They do cross, so they're not parallel, but in order to be perpendicular, they have to be at a 90-degree angle, right? So that one might be a good one to see something that's neither, right? But I'm trying to hunt down one that is perpendicular. Negative 3x plus 4y equals 4. How about that? Trying against 4x plus 3y equals 5. Hey, it looks pretty good. Let's try this one. Which one was that? 75. Mm-hmm. 75, negative 3x plus 4y equals 4. And 4x, you know what I might do? Because I have to solve these both, 4x plus 3y equals 5. Maybe if I put them side by side like this, we can have it all on the same page, so I'm not scrolling so much. But usually if you're doing it, I would prefer to have them kind of side, or one on top of the other. But this is fine, as long as you give enough space here so it doesn't look like one big thing. Solving for y, I get 4y is 4 plus 3x. So y is 4 plus 3x over 4. So y is 1 plus 3 over 4x, right? Skipping a step because 4 over 4 is just 1, so I can ditch the fraction if I want to. Same thing for the next side, 3y is 5 minus 4x. Doesn't want to write anymore. Y is 5 minus 4x divided by 3. So y is 5 over 3 minus 4 over 3x. So what I've got is m1 is 3 over 4, and m2 is negative 4 over 3. So going back to our notes here, blah, 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 here, you could look at one of these and say, well, it's the negative reciprocal of the other. But I actually find that it's easier if you're able to show that m1 times m2 equals negative 1, then they are perpendicular. So what I'm going to say is, since m1 times m2 is 3 over 4 times negative 4 over 3 equals negative 1 because 3 and 3 are going to cancel, 4 and 4 are going to cancel, and I'm just left with negative 1 over 1, which is negative 1. These two lines are perpendicular. Another thing that might be useful is if I asked you, okay, let's use one of these lines here. Let's find a line that is perpendicular to, or the slope of a line that's perpendicular to some point or some other line. Example, I'll use one of these lines. Find the slope of a line, or let's kick it up a notch. Find the equation of a line, right? No, we'll start with find the slope. Slow down, Emily. Find the slope of a line that is perpendicular to 7x minus 3y equals 2. Okay. First, I need to find the slope of this line, and then I can take the negative reciprocal of that slope, and that's the slope of the line that's perpendicular to this line. So I get negative 3y is 2 minus 7x. So y is 2 minus 7x over negative 3. Putting me at y equals 2, but I'll bring that negative up to negative 2 over 3 plus 7 over 3x. So here m1 equals 7 over 3. The slope of a perpendicular line is m2, which from our notes is negative 1 over m1. Okay. Good thing we know how to deal with fractions, right? m2 is negative 1 over 7 over 3. Fraction over a fraction, right? Flip and multiply. And so we get m2 is, now just to illustrate, right, again, I'm going to stop doing this eventually, but negative 1 over 1 over 7 over 3 is negative 1 over 1 times 3 over 7. So m2 must be negative 3 over 7 if you multiply those fractions. Okay. Good. All right. So that's lines. Let's just flip quickly, or briefly rather, to 1.11, but it's really just going to be using Desmos to solve things. So use Desmos to graph equations and inequalities. Definitely use it to check your work. And like we mentioned earlier, you will have it during the test. So definitely, you know, try it out and get comfortable with it. In general, right, if you ever see, so in the little problem sets here, if you ever see a little calculator, graphing calculator symbol, you absolutely can use your TI-83 or 84 or whatever they're on now. But I think Desmos is a little bit quicker, a little bit cleaner, and definitely easier to enter your equations into. Okay, so if you're solving an equation, right, usually you're solving for x. And so what I want to highlight in this section is that if I ask you to solve something algebraically, right, it just means use math to solve for x, right? So here, right, if you've got 3x minus 4 equals 1, and I ask you to solve it algebraically or just solve it means algebraically, then you're just solving for x. Whereas here, if I ask you to solve something graphically, right, usually we just check our work graphically, but sometimes I ask you to solve it graphically. Then, right, if we want to have, so if we graph the resulting equation, so you don't even need to move all the y's over to one side or solve for y, because Desmos is really clever. So if you have y equals 3x minus 5, right, or you could plug in 3x minus 4 equals 1, then here it'll just give you the line. And then where this thing equals 0 is on the x-axis. Okay? Usually, if we're solving for two lines where they cross, where we find the intersection, right, you can just use Desmos and find the point where they intersect. So here, these equations you can solve both algebraically and graphically, and so let's try solving 15 graphically. Okay, so because we can't solve this, or we can, but we're not going to solve this algebraically because it's to the power of 4, so generally we stay away from those in this course. But if we have x minus 5, let's see here, delete these two, and so bracket x minus 5, bracket, and then if you want something other than the power of 2, there's the a to the power of b, which for the longest time I couldn't find it. It looks a lot like a squared, but it's in the left-hand quadrant there, and you hit the a to the power of b to bring that cursor upstairs to the power of 4, and then you need to step it down again, right? Otherwise everything's in the power. So you just click it, and then minus 80. Whoops. I'm gonna zoom out here. Sometimes you have to zoom out a lot. Okay. What happens if I put equals 0? Nothing. Just keeps going and going and going. I'm gonna ditch the equals 0. Oops. Okay. Whee. So where does this thing equal 0? It equals 0 at 2.009. It's probably an approximation, but also at 7.991. Okay. So if we have to solve the equation graphically, right, especially if we have some interval, typically what's going on is there's weird stuff going on outside that interval. And so if they ask you to narrow down your window, then definitely do that. Only look between 0 and 6. So if we have x squared minus 7x plus 12 equals 0, we know how to solve this algebraically because we use the quadratic formula. I see that this is a quadratic equation, so I can use the quadratic formula to find the solutions. The solutions are where it crosses the x-axis. So if that's between 0 and 6, I'm not sure, but if we have x squared, so if I go in here, because we're only doing it graphically now, so I have x squared minus 7x plus 12. And remember they said, I don't have a pointer on Desmos, but between 0 and 6, right, is where I want to have, so I only want to focus my attention here between 0 and 6, which is, now I've got 6 on the board here. But it looks like if I click on my line, looks like 3 is a solution where this thing equals 0, right? And 4 is a solution, so x equals 4 is also a solution where this thing equals 0. The last thing we can look at for solving things graphically, and graphically is really just, I'm not going to test you on making things graphically, that doesn't make sense. It's really just a tool for you to check your work. So if you're working with inequalities like last day, right, then like I showed you at the beginning of class, then you could graph whatever you're trying to solve and figure out when it's true using your graph, right? And so if we have something like, let's look at 33, looks nice and calm. Now, are there, okay, so I want to try using the inequalities here. It might work, it might not work. I haven't tried it before. So x squared, just typing it in, has to be less than or equal to 3x plus 10. Okay. Okay. Looks like that happens between x equals -2 and x equals 5. Let's see what happens. So what if I put everything to one side? So if I have x squared minus 3x minus 10, x squared minus 3x minus 10, right? Moving things over to the other side, okay? Then this is the actual graph, right? I guess when I put the inequality in, it only shows the region where it's true, okay? So, oh man, I wish I had a pointer here. Anyways, when we draw that graph, the blue graph, right, the inequality, once I moved everything over to the left-hand side, I would have 0 on the right-hand side. So I'd have x squared minus 3x minus 10 is less than or equal to 0, right? I didn't multiply by negative, so everything's fine. X squared minus 3x minus 10 has to be less than 0. So looking at this graph, everything below the x-axis has to be, is when it's negative, and everything above is where it's positive. So it makes sense that these 2 points are the same, right? So that's where it crosses into negative territory. And because it's less than or equal to, it's inclusive of these points. Okay, so let's make a note of that. Try to keep it on this one page, but graphing x squared less than or equal to 3x plus 10 in Desmos shows the region where this is true. Maybe I'll need to put it on a fresh page. I tried. Sure. Where this is true, if we move all the terms to one side of the inequality, we get x squared is less than or equal to 3x plus 10. So then we have x squared minus 3x minus 10 must be less than or equal to 0. If we graph this, graphing this gives something like, I'm going to try to copy it here, a -2 and +5. Something like that. Right? And then where it's less than 0, that's from this point, less than or equal to 0, that's this whole region, right? All of these y's are 0 because it's all below the y-axis. And so here, the region where this is true is that shaded region that it gave us originally. So just be careful of what you're giving it, right? Because when we gave it the inequality, what's nice is it just tells you, hey, this is where it's true. But in order to actually see what the graph looks like, you need to move everything over to one side and have 0 on the other side, right? Because then you can just graph this. Nice. I think we're done with the fundamentals. Actually, I know we are. Are there any questions? So we'll, I'll have a practice test up for you guys over the weekend. And then hopefully I'll send out an email to you guys when it's posted. And then, yeah, took a long time to get through those fundamentals. I know, they're really important though. And it's honestly about a third of the course, so we're still fine. But now, I know, calling them fundamentals is not very cool, but they are fundamentals, so, but we're gonna build on all these all course. So once I have a practice test for you guys, I'll let you guys know, and then we'll talk more about the test on Tuesday, and then you'll have your test on Thursday. Any questions? So for practice in general, right, go through and do, just pick some questions from the notes, and then you can check your work against the solutions that I've posted. So you've got lots of practice problems. Good. I'm not seeing any questions come in. Not really. Rational versus real numbers, no, it's going to be more like do this, solve this, factor this, expand this, that kind of stuff. So not a ton of theory, no. I expect you to kind of have a good handle on it, but mostly numerical. Yeah. I mean, taking an example that we just did, right? If I ask you to find something that's perpendicular, right? Find the slope of a line that's perpendicular to this line. It assumes a theory, right? So it assumes that you know what that means, but then it's all numerical after that, right? So, but I won't be doing definitions or anything like that. Great. Okay. Awesome. Have a great Thanksgiving. And we'll see you next week.